Every single day, this factory turns raw ocean seaweed into 40 million crispy snack sheets, enough to stretch from Seoul to Tokyo and back. Off the southern coast of South Korea, the ocean is farmed as intensively as any field on land, growing the raw material for a snack industry worth over $4 billion a year. Every sheet of seaweed snack you've ever eaten started here, pulled from the ocean by hand and processed within hours before it begins to degrade. From tangled ocean weed to a perfectly crispy snack in every convenience store on Earth. This is how seaweed becomes food for millions. The distinctive dark green pouch is recognized worldwide. Korean seaweed snacks have crossed over from Asian specialty stores to mainstream supermarket aisles in every major Western market. Inside this facility in Wando County, 300 workers process over 200 tons of raw seaweed per Dalton Y during peak harvest season. South Korea produces over 60% of the world's seaweed snacks. The country's southwestern coast provides the ideal combination of cold nutrient-rich currents, tidal range, and centuries of cultivation expertise. For centuries, Korean coastal families dried seaweed by hand on bamboo racks in the sun. The modern factory achieves in 90 minutes what sun-drying took 2 full days to accomplish. Beyond the seaweed itself, the facility consumes over 300 tons of sesame oil, 50 tons of sea salt, and 800 kilometers of packaging film per year. This single facility produces over 3 billion individual seaweed snack packages per year, shipped to 68 countries across 6 continents. The journey begins in these sheltered bays where seaweed has been cultivated for over 300 years, a farming tradition older than most nations. Flavor, known as gim in Korean and nori in Japanese, is the species used for snack production. It grows on ropes suspended just below the ocean surface where sunlight penetration is optimal. Each cultivation rope produces roughly 5 kilograms of wet seaweed per each harvest cycle. The farms in this bay alone contain over 50,000 ropes. Cultivation begins each autumn when farmers seed ropes with microscopic laver spores. The spores attach to the rope fibers and begin growing as ocean temperatures drop below 15 degrees. The growing season runs from October through March. Cold, nutrient-rich winter currents providing the minerals and nitrogen that give laver its distinctive umami flavor. Tidal exposure is critical. Seaweed that alternates between submersion and air exposure develops thicker cell walls and more intense flavor than continuously submerged crops. Rope depth is adjusted throughout the season. Deeper ropes produce longer blades, while shallower placement triggers the tidal exposure stress that develops thicker cell walls and richer flavor. The tidal rhythm is the farmer's most powerful tool. No fertilizer or chemical input is needed. The ocean provides all nutrients, while tidal exposure naturally strengthens the crop. Mechanical harvesters cut the seaweed at rope level, leaving the holdfast attached so the plant regrows for the next harvest cycle, 4 to 6 weeks later. A single boat harvests up to 3 tons of wet seaweed per Dalton Yai. The harvest must reach the processing facility within 6 hours. After that, enzymatic degradation begins destroying flavor and texture. Every delivery is graded at the dock. Color, blade thickness, and freshness determine the price paid to the farmer, creating an incentive system that rewards careful cultivation. During peak harvest, every boat in the bay operates from dawn to early afternoon, racing to collect as much seaweed as possible before the afternoon processing deadline. A productive farming family manages 500 to 1,000 ropes across 4 to 6 harvest cycles per season, generating annual revenue of $30,000 to $60,000 from ocean real estate that costs nothing to fertilize. Boats dock directly at the facility, eliminating truck transport time. The shortest possible chain from ocean to processing preserves the delicate compounds that create premium flavor. Each delivery is weighed, sampled for quality, and tagged with harvest location and time. Traceability begins at the dock, every package traceable to the specific bay and harvest date. Inside the facility, the first step is washing. Raw seaweed carries salt, sand, small shellfish, and other marine organisms that must be completely removed. 3 consecutive wash cycles in fresh water reduce salt content to below 1%, critical for achieving the clean flavor profile consumers expect. Heat recovery captures waste energy from the exhaust and redirects it to preheat incoming air, reducing the drying tunnel's energy consumption by 30% compared to single-pass systems. Dewatering removes surface moisture without damaging the delicate cell structure. The seaweed must retain enough moisture for the sheet-forming stage that follows. Sheet forming is the most critical step. The seaweed slurry is spread to precisely 1.5 millimeters thick across a moving screen. Uniformity at this stage determines the final product's consistency. Pre-forming inspection catches debris missed by mechanical washing. A single fragment of shell or stone embedded in a sheet would crack equipment and contaminate an entire production run. The continuous wet sheet moves at a constant speed. Any variation creates thin spots that tear during roasting or thick spots that don't crisp properly. The drying tunnel stretches 40 meters, carrying the wet sheets through ascending temperature zones that reduce moisture content from 85% to under 5%. Initial drying at 50 degrees is gentle. Too much heat too fast causes the sheets to curl and crack. The temperature ramps gradually over the full tunnel length. 5 temperature zones replicate the traditional sun-drying process in a controlled environment, achieving in 90 minutes what oceanside drying racks took 2 full days to accomplish. Dried sheets emerge at precisely 4.5% moisture, crisp enough to shatter when bent sharply, but flexible enough to survive handling without crumbling. Precision cutting trims every sheet to identical dimensions. Trim waste is collected and reprocessed into seaweed powder and flakes. Zero raw material goes to landfill. At magnification, the cellular structure reveals why seaweed crisps so well. Each cell wall contains complex polysaccharides that shatter under heat stress, creating the characteristic crunch. Optical grading sorts sheets into 3 quality tiers in real time. Premium grade goes to sushi nori production, standard grade to snack lines, and economy grade to flake and powder processing. At this stage, the sheets are raw dried laver, the base material used in sushi rolling. But the snack transformation hasn't begun yet. The snack transformation begins with sesame oil. Rotating brush rollers apply a precisely measured coat to each side. The oil providing flavor, crispness, and the distinctive golden sheen. Oil application must be exact. Too much, and the sheets become greasy and heavy. Too little, and they don't achieve the signature crispy texture during roasting. Sea salt follows the oil. Fine ground crystals distributed in a controlled curtain that delivers precisely 1.2 grams of salt per standard sheet. 6 flavor lines run simultaneously. Original sesame salt accounts for 40% of production, with wasabi, teriyaki, spicy gochugaru, and barbecue sharing the remainder. Each flavor requires its own seasoning formulation, application rate, and roasting temperature. 6 distinct production recipes running on parallel lines. Seasoning calibration happens before every production run. Each flavor has a target weight, per seat measured to 1/10 of a gram, the difference between subtle enhancement and overpowering salt or spice. Roasting is where chemistry becomes flavor. Infrared heat triggers the Maillard reaction, the same chemistry that makes toast golden and steak seared, creating hundreds of complex flavor compounds. Roasting temperature reaches 210 degrees for exactly 12 seconds. A 2-second deviation either undercooks, leaving the sheet chewy, or overcooks, turning it bitter and brittle. The transformation is immediate. What entered as a flat-oiled sheet exits as a crispy, aromatic snack. The signature seaweed crunch created in those 12 seconds of intense heat. Rapid cooling locks in the roast. Without immediate temperature reduction, residual heat continues cooking the sheets for several minutes after exiting the tunnel, destroying the precise texture balance. Post-roast quality control checks every batch for color, crispness, and flavor. The snap test is simple. A properly roasted sheet breaks cleanly with an audible crack. Robotic palletizing stacks cases in configurations optimized for each container type, maximizing load density and minimizing wasted shipping space. Post-roast moisture must be below 3%. Any higher and the sealed package develops internal humidity that destroys crispness within weeks. Quality inspectors are trained to identify roast levels by sight. Color deviation beyond the acceptable range triggers immediate line adjustment, preventing entire batches from failing specification. Optical counting ensures every pack contains the exact number of sheets. The machine counts and stacks at a rate of 300 packs per minute per line. Nitrogen flush packaging replaces oxygen inside each pouch, preventing oxidation that would make the seaweed stale within days. Sealed properly, shelf life extends to 12 months. The nitrogen flush happens in milliseconds, displacing over 99% of the oxygen inside the pouch before the seal locks. Any residual oxygen accelerates rancidity of the sesame oil. The packaging is engineered as a microenvironment. Multi-layer foil blocks light and moisture. Nitrogen prevents oxidation, and an oxygen absorber sachet captures any residual gas. Every package passes through metal detection and weight verification. A single contaminated package reaching a consumer could trigger a recall costing millions. Sensory testing happens hourly. Trained panelists score every batch for appearance, aroma, crispness, flavor intensity, and aftertaste. Any score below threshold halts the line. The sensory panel maintains calibration by testing reference samples weekly. Flavor drift of even 5% from the standard profile is enough to fail a batch. Hybrid formats combining seaweed with rice, corn, or quinoa are expanding the snack category, creating textures and flavor profiles that appeal to consumers unfamiliar with traditional sheet seaweed. Retail boxing runs at the same pace as pouch sealing. Any bottleneck between the two stages creates a backup that can halt the entire production line within minutes. Every box carries batch-specific traceability data. A consumer in New York can scan the code and trace the product back to the specific harvest bay and processing date. Master cases are palletized by robotic arms, 12 cases high, 6 across, creating stable shipping pallets that maximize container utilization for ocean freight. Language-specific labeling is applied at the case level rather than the package level, allowing the same core product to ship to any market with a simple outer label change. The warehouse holds up to 30 days of finished inventory, over 200 million individual snack packages waiting for distribution across 68 countries. Container ships from this port reach Shanghai in 3 days, Los Angeles in 12, and Rotterdam in 28. Seaweed snacks traveling by ocean just as the raw material once traveled by boat. The United States is now the fastest growing export market, consumption increasing over 20% annually as seaweed snacks enter mainstream grocery and convenience channels. In Korean convenience stores, seaweed snacks occupy an entire aisle, dozens of brands and flavors competing for the attention of consumers who eat seaweed daily. In American retail, seaweed snacks have migrated from specialty Asian food aisles to mainstream snack sections, driven by health-conscious consumers seeking low-calorie alternatives. The global seaweed snack market has grown by over 200% in the past decade, driven by health-conscious consumers in North America and Europe, discovering what Asia has known for centuries. The children's lunchbox market has been a breakout category. Parents seeking healthy alternatives to chips and crackers are driving double-digit growth in family-sized seaweed snack packs. Research and development drives the next generation of seaweed products. Beyond traditional roasted sheets, the industry is expanding into chips, crisps, and seasoning formats. Seaweed chips, layered sheets bound with rice starch and fried or baked, represent the fastest-growing product format, targeting consumers who prefer chip-style crunch over sheet-style snacking. From a single raw material, this facility produces 11 distinct product formats, each targeting a different consumer occasion and price point. Protein yield per hectare of ocean surface exceeds most land-based crops. Seaweed farming produces 10 times more usable biomass per square kilometer than soybean cultivation. Premium sushi nori commands 3 to 5 times the price of snack-grade seaweed. Each sheet is individually backlit and inspected for color uniformity, thickness, and tear resistance. 3 grades emerge from the same harvest. Premium goes to sushi restaurants, standard becomes snacks, and economy grade is processed into flakes and powder. In Korea, gimbap, seaweed, wrapped rice rolls, is as ubiquitous as sandwiches in the West. The facility supplies over 15,000 restaurants with premium sheet-grade product. Seaweed is woven into Korean food culture far beyond snacking. Birthday soup, rice accompaniments, salads, and wraps all depend on the same ocean crop, processed in different ways. Nothing is wasted. Sheets that don't meet visual standards are ground into furikake, seasoning flakes, and seaweed powder, premium condiments in Asian and increasingly Western cooking. Korean seaweed farming is recognized by UNESCO as an intangible cultural heritage practice, a tradition spanning centuries that has evolved from bamboo frame cultivation to to modern rope systems. Flavor changeovers require complete line cleaning. Residual wasabi oil contaminating a batch of original sesame would fail quality control and waste an entire production run. 300 years ago, Korean farmers discovered that laver spores would colonize bamboo frames placed in tidal zones. The basic principle hasn't changed, only the scale and materials. Modern spore production happens in shore-based hatcheries. Laver spores are cultivated on oyster shell fragments in temperature-controlled tanks, providing farmers with consistent high-quality seed stock. Seeding happens in autumn when water temperatures drop below 18 degrees. The spores germinate within days, producing visible blades within 2 weeks of deployment. Farmers inspect their crops weekly throughout the growing season, checking for disease, adjusting rope depth, and monitoring growth rates to predict optimal harvest timing. The nutritional profile explains the health food marketing success. Seaweed delivers protein, minerals, vitamins, and omega-3 fatty acids at just 5 calories per standard snack serving. Disease is the farmer's greatest fear. Green rot and red rot can destroy an entire section of cultivation within days, spreading through water currents to neighboring ropes. Climate change is increasing disease pressure. Warming ocean temperatures extend the range of bacterial pathogens while shortening the optimal growing season for cold water laver species. Iodine content is closely monitored. Seaweed is the richest natural source of iodine, essential for thyroid function, but excessive levels require labeling in European export markets. Wash water contains salt and organic matter that must be treated before discharge. The on-site system reduces biological oxygen demand by over 95%. Rooftop solar generates over 30% of the facility's electricity. The drying tunnels, the most energy-intensive stage, are supplemented with waste heat recovery from the roasting ovens. 200 tons in, 40 million packages out, 3 quality grades, 11 product formats, 68 countries. Every single day during harvest season, seaweed farming requires 0 freshwater, 0 fertilizer, 0 pesticides, and 0 arable land. The crop actively absorbs carbon dioxide and nitrogen from the ocean, improving water quality as it grows. Studies show seaweed farms measurably improve surrounding water quality, absorbing excess nitrogen from agricultural runoff that would otherwise cause harmful algal blooms. Seaweed farming is increasingly recognized as a climate solution. Cultivated seaweed absorbs carbon dioxide at rates comparable to terrestrial forests, without competing for land. Research institutions are racing to develop heat-tolerant laver varieties. Current commercial strains stop growing above 20 degrees Celsius, a threshold being crossed earlier each year in traditional growing regions. Global seaweed production has tripled in 2 decades. South Korea, China, and Indonesia lead production, but new farms are emerging in Norway, the UK, and the American Northeast. Back inside the facility, all 6 production lines are running at maximum throughput, processing today's ocean harvest into tomorrow's snack shelves across 68 countries. The roasting tunnel is the heart of the operation. A single degree of temperature variation or a half-second timing change alters the final product's flavor and texture. As the day's final shipments depart, the cleaning crews begin their work, preparing every surface for tomorrow's production, when the ocean will deliver another 200 tons of raw seaweed. Wando County's economy is built on seaweed. The farms, the factory, the harbor, the supply chain, an entire community sustained by what grows on ropes in the ocean. At peak throughput, the 6 lines produce over 200,000 sealed pouches per H, hour enough to fill a standard shipping container every 90 minutes. Real-time production tracking ensures customer orders are filled on schedule. A single packaging machine breakdown requires immediate reallocation across remaining lines. 2 12-hour shifts keep the facility running 24 hours during the 6-month harvest season. When the ocean delivers, the factory processes. There's no pause button on perishable raw material. International buyers visit the facility to verify quality systems before placing orders. A single retail chain contract can represent 50 million packages per year, making facility tours a critical part of the sales process. 6 international certifications allow the facility to export to virtually any market on Earth. Each certification requires annual audits and continuous compliance monitoring. From ocean to sealed package in under 24 hours, from sealed package to store shelf in 1 to 4 weeks, depending on destination. Export compliance requires country-specific documentation. Japanese labels need different allergen warnings than European labels, which need different nutritional panels than American labels. 4 versions of the same product for 4 different regulatory environments. Each label legally required to display different nutritional information, allergen warnings, and import certifications. End-of-day reviews catch quality trends before they become problems. A gradual shift in roast color across the day might indicate oven calibration drift requiring overnight maintenance. The 300 workers in this facility represent an entire coastal community's livelihood. Many families have both a seaweed farmer and a factory worker. Their income tied to the same ocean crop from both ends. Overnight maintenance keeps the operation running at peak performance. A single shift of unplanned downtime during harvest season wastes up to 15 tons of perishable raw seaweed. The farmers who grow the seaweed and the workers who process it share a common purpose: turning what the ocean produces into food that nourishes millions of people worldwide. 40 million sheets per Dalton UI, 3 billion packages per year. 6 continents, 0 fresh water, 0 pesticides, 1 simple ocean plant. That is how tangled ocean weed pulled from a Korean bay becomes the crispy seaweed snack in your hand. Food for millions, grown by the sea. From an ancient ocean plant to a modern global snack, from a Korean bay to every continent, from a farmer's rope to your convenience store shelf. If this journey fascinated you, subscribe and hit the bell. Next time, we're heading inside a factory where sand becomes a $2,000 graphics card.